Well, hello and welcome YouTube. Mr. Robinson back here with yet another brand new exciting video, all math basic course. And as always, it is an honor and a privilege to be serving you today, as it is every day here in my virtual classroom. Step on inside as we do the Chapter 1 Test and Cumulative Assessment in the Big Ideas Math Integrated Math 1 textbook. Now, we just came off the Chapter 1 review, if you watched that one, where I went deliberately pretty slowly, actually. Teaching every section, they had examples with each part, going very slowly through each problem. This one's going to be, as I stated at the very end of that video, less teaching, more doing. My goal is to say, you should try these ones for yourself. You can download this, by the way, in the description section down below. Try this one for yourself and compare to what I do here. For me, it's just like, we're now testing it, and now I'm just going over the problems kind of whip fast. It's like me going over an answer key for a test in my class after we've done the chapter. It's not this slow thing unless you stop for questions, in which case ask a question in the comments down below, whatever it is you want to do there. But like I said, you can download this in the description section. There are two parts to it. There's the Chapter 1 test, and then there's the cumulative assessment. Now, the majority of cumulative assessments for this book will be building off questions from previous chapters. The only chapter we've done so far is Chapter 1, so every question we're going to do is based off Chapter 1. So the first set of questions we have, let me see, we do 16 questions for the Chapter 1 test and then 9 questions for the cumulative assessment. As a total, that's 25 questions. Some of these questions can get a little screwbally, especially in the cumulative assessment. They do more of this matching, multiple choice, this exploration of thinking. So things can look a little harder. It's not always the exact same, and the order can be completely scattered. So keep all that in mind when we do it. And like I stated, kind of treat it like a test all the same. For me, less teaching, more doing. We'll go ahead and get started right here. We're going to start with numbers 1, 2, and 3, where they say solve the equation, justify each step, check your solution. These can be any combination of single-step equations or multi-step equations, including variables on one side. So when I see these ones, number 1, I see out of section 1.1. Number 2, I see out of section 1.2. And number 3, I actually see out of section 1.3. They're mixing and matching them. All right, number 1, we have x minus 7 equals 15. If I add 7 to both sides here, I'll get x by itself. I get x equals 22. My double check to see that 22 minus 7 is indeed 15, and that equals that side. We're all good. So you can see I'm going faster. Not only that, as we did later in the sections, I'm not even color coding the adding 7 or anything. Number 2, 2/3 x. I was like, look, Pa, aren't you proud of me? I'm staying inside the lines. All right, anyway, from here, I'm going to subtract 5 from both sides, like so. Now, 2/3 doesn't become an exact decimal, so we have to kind of leave it as 2/3 here. 2/3 x is -2. To solve for this thing, we're going to multiply by the reciprocal of 3 halves. 3 divided by 3 is 1, 2 divided by 2 is 1. And here, 3 halves. -2 divided by 2 is -1. -1 times 3 is -3. So here we'll get x equals -3 as the answer. We're going to have to deal with fractions every so often. Now, if you double check that, 2/3 of -3 is -2. -2 plus 5 is 5 minus 2, which is 3. So that works. Number 3, we have variables on both sides of the equation. We have 11x plus 1 here and -1 plus x on the other side. I'd like to get x's on one side of the equation. I want all my x's to live in the left side of the problem. So I'm going to subtract x from both sides. Remember, that doesn't cancel out the x's. That's minus 1x. 11x minus 1x is 10x. Now, when I subtract 1 from both sides to move these to the right side of the equation, -1 minus 1 is not 0, but -2. You divide both sides not by -2, but by 10. I know you're compelled to want to divide by the -2 because it's a smaller number, but we divide by the number multiplying by x. -2 over 10 is exactly -0.2, but as a fraction, reduce, divide top and bottom by 2, you get -1/5. So x is either or. I prefer the fraction, but the decimal also works. Okay, numbers 4, double check this. -1, let's do -0.2. -0.2 times 11 is let me write that. -0.2 times 11 is -2.2. And here we have -1 plus -0.2. -2.2 plus 1 is -1.2. -1 plus -0.2 is -1 minus 0.2. And that gets you -1.2 there. So that one does check out. That one's harder to kind of say out loud, so I wanted to write it. All right, numbers 4 through 9 says solve the equation, doesn't ask you to double check, and we have a variety of different problems. Some are absolute value, like numbers 4, 5, and 8, and then numbers 6, 7, and 9 involve some form of simplifying terms, distributing, things like that. So a great mix of things. Remember, the entire chapter is on solving linear equations, so it's kind of hard to get around these kinds of problems. You're like, oh, another one of those? Well, they could give you less problems, but they're going to give you different cases, I'm sure. So keep in mind, each absolute value equation is probably going to present something different, which is good. 2 times the absolute value of x minus 3 plus, or minus 5 equals 7. First thing I want to do is add 5 to both sides. My goal here, guys, and I'm not going to distribute the 2, but my goal of, obviously, besides solving for x, is to get the absolute value portion by itself on both sides of the equation. Therefore, I will divide both sides by 2 here as well, because 2 is multiplying by the absolute value quantity. Again, x is inside of there, but I can't penetrate the absolute value with anything, at least not without knowing what consequences there may be. So I'm getting the absolute value by itself. It says the absolute value of something equals 6. So that something, the x minus 3, can either be 6 or negative 6, because the absolute value of either 6 or negative 6 is indeed 6. If I add 3 to both sides of this equation, I get x equals 9. And if I add 3 to both sides of this equation, then I get x equals negative 3. Now you can double check that. I'm going to be fine with those answers being what they are. I'll show you when double checking is a little more required here. But that should be your 2 answers for the absolute value set. Number 5, we have absolute value of 2x minus 19 equals 4x plus 1, not wrapped in an absolute value. Now keep in mind, absolute value is by itself, so we're in our phase of either this number, absolute value of this number either this number equals the positive version of this number, or this equals the negative version of this number. It's hard to see 2x minus 19 as a single value, or 4x plus 1 for that matter, but that's exactly how we have to treat this. So negative quantity 4x plus 1. So they involve the same 2 steps. Well, actually, no, they don't. Here we're going to solve for x. I prefer to keep my x's positive, so I'm going to subtract 2x from both sides here. Consequently, I'm also going to subtract 1 from both sides here. That's negative 20 equals 2x. If I divide both sides by 2, I get x equals negative 10. Now over here, I have to distribute this negative into both of these terms. And here we'll get negative 4x minus 1. Now I'm going to choose to add 4x to both sides here. Strategically, it keeps my variable terms positive, so that works out to me. I'm going to add 19 to both sides here. Hey, it turns that positive as well. I think it works out in my favor in that case. 2 birds, and it's on the left side of the equation. 19 minus 1 is 18. If I divide 6 by both sides, I get x equals 3. Now you can double check this one, and heck, I will as well. Because if I substitute 3 in here, all should be good. 2 times 3 is 6, minus 19 is negative 13. Oh no, but that's okay. Absolute value of negative 13 is positive 13. And 4 times 3 is 12, plus 1 is 13. X equals 3 is all good here. Left side equals right side with absolute value. The problem with this side is, and it doesn't matter what I evaluate here, plugging in negative 10 gives you a negative result. Not just because the 10's negative, but by plugging it in. 4 times negative 10 is negative 40, plus 1 is negative 39. Now, if you do everything within here, you're actually going to get absolute value of negative 39 equals negative 39. And that's not a true statement. That is not a true statement. Absolute value of negative 39 equals positive 39. So this becomes what's called an extraneous solution. And in extraneous solutions, that's not part of your result. The only solution is x equals 3. X equals negative 10 is rejected. So the ones that are worth double checking are when x is outside of the equation, like number 5. Number 6 is not an absolute value equation. It's just a solving for x, but there may be something special to it. We'll see. I have no idea. I've not done the problem yet. I'm anticipating maybe there is, just because the last problem. Ah, yes, there is something special to this problem. Okay, we're going to simplify both sides of this equation. Negative 2 minus 7 is negative 9. We still got the positive 5x here. 3x plus 2x is 5x. We still got the negative 9 here. 5x minus 9 equals 5x minus 9. That's an identity. This is going to be an infinite number of solutions case. I can confirm that even more so by subtracting the 5x's, making them go away, and show that the negative 9 equals negative 9, left side equals right side, regardless of x. This is called infinitely many solutions. What am I writing? Infinitely many solutions. I think the better answer for these, I'm just following what the book said, the better answer for these to me is all real numbers. I can plug in anything for x. Left side will always equal the right side there. We'll probably get a no solution case coming up at some point. We'll find out when. Doesn't appear to be here. Number 7 is just a different form of simplification. We're going to do one of two things for this problem. Either add 1 to both sides to get this quantity by itself right here, kind of like the absolute value equations. And then we can also divide both sides by 3. And because -6 can divide by 3, then this is a good method to go. It makes your numbers smaller all the same. You get -2, and we subtract 4 from both sides, and we get x equals -6. Now, most people don't go about the problem that way, and that's fine. I probably wouldn't unless I really saw from the onset that that's the way to go. We can shrink our numbers. However, we can also go conventionally. You can distribute the 3 into both terms, because it's not an absolute value, it's just a quantity. 3 times x, 3 times 4, and then simplify this side. 12 minus 1 is 11. And then now it's just 2 steps from solving. Subtract 11 from both sides, and then divide both sides by 3. We get x equals -6 still. So it works out either way. In general, you'll probably look to go this way. It depends on what your numbers look like and what you're doing. If it was an absolute value problem, obviously you go about it this method. But yeah, it just depends on what it is. Now, number 8 is an absolute value problem. It seems like number 5 in that there are x's on both sides of the equation, but this time there are absolute values on both sides of the equation, which our setup's going to be the same as before. It either equals the positive or negative version of the other side. In this case, both sets of answers, if 2 exist, should be equal, or should work, because you can take the absolute value of either side. Remember when it said absolute value of negative, oh, where is it? Hold on, let me check. Remember when we said, wait, where was the problem? Where's the problem that we did? Oh, it's down here. I was looking for green. I forgot I turned it red. Remember when we said absolute value of -39 doesn't equal -39, but what if this had absolute value? Well, now they'd be equal to each other, right? So if we have absolute values on both sides, we should be good here. So the inside here equals either the positive version of that inside or it equals the negative version of that inside. Now we saw that as having to distribute this negative, which is what we'll do here as well, because that's a positive quantity, negative quantity. If I want to keep my terms positive, my variable terms positive, I'm going to subtract 2x from both sides, which means subtract 4 from both sides, move it to the left. So I got 16 equals 2x. If you divide both sides by 2, you get x equals 8. Seeming fine. Here, let's distribute the negative. Oh, -4. Distribute the negative. I started to just copy things down. And now I'm going to add 4x to both sides to keep them positive. Looks a lot like that other problem that way. This time when I subtract 20, oh well, negative result. At least I have the positive x's to work off of. This is -24. And when you divide both sides by 6 here, you get x equals -4. Now, don't be intimidated by that -4 answer. When you plug it into both sides, you'll get absolute values of both sides. They'll both turn positive into whatever you're getting there. So you should be good. You can check it. It should be fine. All right, number 9. You have 1/3. 1/3 times 6x plus 12 minus 2 times x minus 7 equals 19. Let's go straight to distribution. Don't try any stuff here. The reason why I'm comfortable doing the 1/3 into these is these numbers can divide by 3. 6 divided by 3 is 2. 12 divided by 3 is 4. Now, -2 is distributing into these. This is -2x and -2 times -7, which is positive 14. Like that. Combine like terms here. 4 plus 14 is 18. 2x minus 2x is 0. So those, in a way, cancel out. So you get 18 equals 19. Now, I did the math right, but 18 doesn't equal 19. This is a case unlike this thing that said -9 equals -9. That was true. This one says no matter what I substitute for x, the left side will never equal the right side. Right side will always just be 1 more than the left side, which is so close, but never gets you a solution. This is no solution. We had infinitely many solutions. Here we have no solution. Okay, numbers 10 and 11 describe the values for C, for which the equation is no solution. Explain your reasoning. Well, we just saw a question like this one, number 10. 3x minus 5 equals 3x minus c. Now, when it comes to the whole idea, right, left side can't equal the right side, but let's exacerbate that a little bit more by subtracting 3x from both sides, let's basically solve for C in this case. -5 equals -C. If you switch the signs here, it would say C equals 5. But here's the thing. They said we want no solution. We want no solution. So basically, if C was 5, you'd actually have infinitely many solutions. There is no value for C I can get where we have just one solution solving for x. X's cancel regardless. What we want is C not to equal 5. If C is any number other than 5, you'll have no solution. Because then instead of saying -5 equals -5, it'll say -5 equals -6, -5 equals 1, -5 equals 0, which are not true statements. Those are the no solution cases. So what values of C give you no solution? Any C number that is not 5. Any number in the world that is not 5. Number 11 says absolute value of x minus 7 equals C. Now, before moving on to the whole x minus 7 is positive C or negative C, we want the no solution cases. In order to get no solution cases, we can't have conditions for which x minus 7 can equal positive or negative version of C. That's if C is a negative number to begin with. Remember, you can't take the absolute value of a number and get a negative as a result. Now, instead of explaining your reasoning, I just realized I have to do that for the previous problem. So I have to do any negative numbers for C. The way I can write that is as an inequality. C's can be less than 0. So let's do explanations for both of these and move forward. This one I just came off of is you cannot take the absolute value of something and get a negative result. That would lead to no solution, which is what we want for this problem, right? We're trying to get no solution. That sounds kind of weird, but that's what we're trying to get for this one. Let's go smaller font in this one probably. So for this one, if C equals 5, it would lead to infinitely many solutions. We want any value other than C, other than 5, for the left side to not equal the right side, for them to not be equivalent. We want a false statement to be made out of that, not a true statement. All right, that's numbers 10 and 11. Number 12. A safety regulation states that the minimum height of a handrail is 30 inches. The maximum height is 38 inches. Write an absolute value equation that represents the minimum and maximum heights. In these, we want the difference between 30 and 38 to be the same. Excuse me. The difference of that number from some number to be the same distance, right? We want to be this many inches, this direction of 38 or 30. Now, between 38 and 30, here's 30, here's 38, is a midpoint. That would clearly be 34. I think you guys can tell that's halfway in between. That's 4 away in either direction. We want 4 to represent the absolute value of the distance between our x's, which would be solutions of 30 and 38, and that 34. So the distance between x and 34 is x minus 34. If we take its absolute value, we will get the distance between, which is 4. That is the answer. 4 units this way or that way, plus or minus 4. The difference between 38 and 34 needs to be 4. The difference between 30 and 34 is negative 4, but take its absolute value, we get 4. Okay, number 13. The perimeter P in yards of a soccer field is represented by the formula P equals 2L plus 2W. Soccer field is rectangular, and in a rectangle you have equal lengths and widths, so that's what they're adding, the 2 lengths and the 2 widths. They said where L is the length in yards and W is the width in yards, solve the formula for W. So solving for W, let's see, I'll put A, this is part A, means get W by itself. So take that equation and subtract 2L from both sides. It's okay that we don't know what L is or if we don't know what P is. I think later they show you what P is. I think they tell you in the diagram, but we're not getting that in that way. We're getting W by itself with variables. So P minus 2L. You divide both sides by 2. This is out of section 1.5, by the way. This is W equals P minus 2L all over 2. Now, there are different ways you can write this, obviously. You could divide P by 2 separately and 2L by 2. But I'm going to go ahead and just leave it like that for now. Part B says find the width of the field. Now, this is where we are going to do our substitution. You can see the perimeter. I don't know if you can see it, actually. This says 330 yards, and it says the length is 100 yards. So we are going to do a substitution. Now that we have width by itself, we can say that the width is 330 minus 2 times 100 all over 2. That's 330 minus 200, right? Which is 130 over 2, which is 65. Because it's contextual, we want to state yards, the units. W is 65 yards. Part C says about what percent of the field is inside the circle. Interesting. So the circle has a 10-yard radius. A 10-yard radius means its area is pi r squared. Area is pi times 10 squared, which is 100 pi square yards. Now I'm going to leave it like that for now. 100 times pi is around 314. That makes sense because 3.14, whatever. We're going to get there. But what we have to do is ask, it says what percent of the field is inside the circle? We're taking the area of that circle and dividing it by the area of the entirety of the soccer field. We haven't found the area of the soccer field yet. This is area of the inner circle. And now we want area of the field. That's length times width. And guess what? Now we have the width of 65. So the length is 100. The width is 65. So that'll be 6,500 square yards. We're going to get the percentage of this. I'll just say percent equals. That looks weird. But the percentage of the area of the circle is taking the area inside of there divided by the area of the entire thing. So 100 over 6,500, which is another way of saying pi over 65. Now I'd like to get that exact number. It's 3.14 divided by 65. It's going to be close to 1/20th, close to 5%. I don't know the exacts. Let's figure it out. I'm going to go to my calculator. I'm going to say pi divided by 65. And if you feel uncomfortable doing the whole, oh, my calculator's not responding. Give me 1 second. Okay, I had to reset it. I don't know why that happened. If I do pi divided by 65, I'll get a decimal. This decimal is the decimal equivalent of some percentage. If you know how decimals work, I'm going to write it like this, around 0.048. If you know how this works, you have to move the decimal 2 places to the right to convert it into its percentage form. This will be 4.8%. Around 4.8% of the field is covered by the circle in the middle. I don't know if that's accurate to most regulation soccer fields, but that's it for this problem. Number 14. Your car needs new brakes. Well, don't tell me things that I don't want to hear. You call a dealership and a local mechanic for prices. So cost of parts is $24 versus $45 at dealership versus local mechanic. Labor cost per hour is $99 versus $89. It says after how many hours are the total costs the same at both places? Justify your answer. This is part A. So what we have to do is come up with equations for these things here. Now, as a whole, and I'm not doing an entire teaching of this, but as a whole, cost of parts is a single cost. It's a one-time payment. At the dealership, you're going to pay $24 for the parts. $99 isn't for the labor, it's labor cost per hour. Every hour is another $99. I guess we can assume a half of an hour is half of $99, things like that, about $50. So when we multiply 90, we're going to add 99, but multiply by the number of hours, I'm going to call it H, the number of hours that they're laboring, that they're repairing it. What are they doing? They're getting new brakes, that they're doing new brakes. So this is the cost, how much you're going to spend at the car dealership. Depends on the number of hours. Now, let's set it equal to the local mechanic's upfront cost of parts plus $89 per hour times the number of hours. We're setting them equal because we're trying to find what value of H you spend the same amount. So we have to find H, solve for H. And don't try and outsmart the problem. Don't try and guess and check. This is the goal. Set it up, solve algebraically. This is dollars plus dollars equals dollars plus dollars. I'm going to subtract 89H from both sides here. And subtract 24 from both sides here. And we are going to get 10H equals, and this looks to be something where we are going to get some form of a decimal, right? So 45 minus 24 is 21, and then we divide both sides by 10, and then we get H is 2.1. This is the amount of hours. It's going to be 2.1 hours. That's not 2 hours, 10 minutes. It's more like 2 hours, 6 minutes. But that's how long it would take. So like I said, it's a fractional amount. It looks like they kind of charge you by the second, really. But it's that amount per hour when it all accumulates. Part B, it says, when do the repairs cost less at the dealership and at the local mechanic? Explain. Now, this is something we don't have to do full math on. This is something we can just make sense on based on the situation that we're looking at. And they never really asked us this question in this section. I forget what section this was. This might be more section 1.3. But they never really asked a question like this, even though I might have said it out loud at the time. Okay, I want you to think of this logically. If you spend $24 up front at the dealership, let's say you bought the parts and then they didn't work on it at all. You said, never mind, I'm going to take them home. I just got the parts. Thank you. You only spent $24. That meant you spent less at the dealership than you would have done the same at the mechanic. $24 is $45. And up till you get 2.1 hours when they equal the same, you would spend more per hour here, but if you spend less hours on it as an overall, up until 2.1 hours, you'll spend less money overall. It's $24 up front. After an hour, it's 24 plus 99, which is 123. Whereas this after an hour is 45 plus 89, which is 134. You spend more at the mechanic. You spend more at the mechanic until you reach 2.1 hours, for which you spend the same amount. After 2.1 hours, the $89 per hour rate ends up lessening over time, right? Think of 100 hours later. These are poor mechanics if it spends that long to repair brakes, to get new brakes. But 100 hours later, $89 per hour, significantly better than $99 per hour, spending $10 less per hour, right? So up until 2.1 hours, at the dealership, you spend less money. You spend less money at the dealership when labor, then repairs take less than 2.1 hours. Whereas you spend more, you spend less money at the local mechanic. You'll spend more money. Listen, you'll spend more money as an overall. You're still spending hundreds of dollars, but you're spending less than at the dealership. You spend less money at the local mechanic when repairs take more than 2.1 hours. Now you could do a table with that and stuff like that. You could try some other numbers, but the point is they're equal, and then one surpasses the other. That's how that's working. Now I spent more time talking about that because that's the first time we got to run in a question of that variety. We haven't seen that one before, so I really wanted to teach that aspect of it. Okay, number 15 says consider the equation absolute value of 4x plus 20 equals 6x. Without calculating, how do you know x equals -2 is an extraneous solution? I'm glad you asked. Because when you substitute -2 for x here, you get a negative number out as a result. Now, as we said before, you cannot take the absolute value of a negative and get a negative result. And here, you would get a negative result. So guess what? I'm going to copy and paste that. Boom. You still get a negative result with -2. Now, that's a common thing that I state. I stated that you get a negative result on the right side, right? Whereas you get positive on the other side. That's the problem. Absolute value of any number other than 0 is positive, and this would give you something that probably says 12 equals -12, and that's just not the case. Said without calculating, though, so there it is. Anyway, that's a common phrase that I stated in section 1.4. You cannot take the absolute value of something and get a negative result. So hear that, understand that, we're all good to go. Number 16, your friend was solving the equation shown and was confused by the result -8 equals -8. Explain what the result means. All right, first of all, trusting that they did everything correct. They distributed 4 into here, all good. They combined like terms there, all good. Combined like terms there, all good. Subtracted 2i from both sides, all good. We saw an instance of this with -9 equals -9. This means you have infinitely many solutions. It means it is an identity. It's an identity. Therefore, you have infinitely many solutions because all real numbers can serve as a solution for x or for y. No matter what I substitute on the left side or right side, any number in existence, any real number, the left side will always equal the right side. Okay. All right, guys, that's it for the chapter test portion. We're going to move on to the cumulative assessment. It's 9 additional questions, and if you haven't seen these kinds of questions before, they are different looking for the most part, and keep in mind these would generally be mixing review from all the chapters. They might emphasize the most recent chapter at times, but because we've only done chapter 1, these will all be from chapter 1. So let's take a look at what these questions look like here. Notice their appearance is just different, right? That's all I wanted to state, that they're just different. Sometimes multiple choice, sometimes exploration, things like that. Sometimes they're normal. Number 1, A mountain biking park has 48 trails, 37.5% of which are beginner trails. The rest are divided evenly between intermediate and expert trails. How many of each kind of trail are there? Actually, that doesn't really sound like much of these kinds of questions, but there's probably some sort of phrasing of it. Now it says there are 48 trails total, right? We have 37.5% that are beginner trails. So that means if number of beginner trails is B, you take 0.375 times 48, and you'll get that B right there. B equals 37.5% of 48. So 0.375 times 48 gives you 18. So there are 18 beginner trails. Now it says the rest are the others here, divided evenly between intermediate and expert trails. So the fact there are 18 beginner trails means that D and A are out. It says the others are divided evenly. We could set up an entire equation of this. If I go straight from multiple choice, you can see that the option's B. If we did this as an actual equation, I would be doing 0.375, which we found out what this was, times 48, plus the two x's that divide evenly to become 48. Now that would become 18 plus 2x equals 48. As you can see, this can become one of these kinds of problems. Subtract 18 from both sides, and 2x equals 30, and x equals 15. Now x represents the number of trails for each of the other ones. Because they're equal, x is 15. So it's 18 beginner, 15 intermediate, 15 expert. The option is B. So it's a workaround, right? You can mix and match in multiple choice, but ultimately you can also do it yourself if you know what you're doing yourself. Okay, number 2. Which of the equations are equivalent to CX minus A equals B? So this is one where we have to probably look at each individual one. It's not just do things to this one and figure it out, but part of it may be that, because they might do some more with it. Check out the first one. CX minus A plus B equals 2B. Well, the original equation said CX minus A equals B. Notice that they clearly added B to the left side of the equation. If I add B to the right side of the equation, what do I get? I get 2B. So this first one works. That actually is one that works here. Does it lead me toward an answer of solving towards something? Maybe not. No, they're just asking you, are they equivalent? The answer is yes, these are equivalent, and that's the whole point. You can do anything to one side of the equation as long as you do to the other side. This is an important skill to, this is an important topic to really make sense of. 0 equals CX minus A plus B. CX minus A plus B. If you see that CX minus A is on this side of the equation, what do I do to make this side be 0? I'd have to subtract B from both sides like this. This would give me 0 over here. That says CX minus A minus B, but this one says plus B. So it's not going to be plus B. This is not one of your options. We don't add B to both sides. We would subtract if we want to make it equal 0. The next option says 2CX minus 2A equals B over 2. That kind of looks like that we're multiplying this left side by 2. That 2 distributes into both of these. But B didn't get multiplied by 2. B got divided by 2. You can't multiply by 2 on one side, divide by 2 on the other side. Doesn't look like this is an option there. So we keep moving along. So this looks like multiple selection now, not multiple choice. Next one. X minus A equals B over C. This is an interesting one to talk about because, now this might not make as much sense with letters, but there are a lot of times people will do something like this. So when he says CX minus A equals that, right? If I divide by C like that, oh look, that worked out because this cancels whatever. But you forgot to divide the A by C as well. This too needs to divide by C. You can't just pick and choose which ones you divide by C. And I bring that up because, and I'm trying to think of the problems that it would happen in. I'm really struggling to think about which ones that they are, because generally in these other problems you wouldn't do this. But if I had like 2x plus 3 equals, 20, some people might go like, oh yeah, divide these by 2, boom. And then you got x plus 3 equals 10. You can't do that. 3 has to divide by 2 as well. That's the very reason why we tend to subtract 3 first. We combine them, so both 20 and negative 3, combined or not, both divide by 2. But you got to divide them all by 2. You can't just pick and choose which ones. I don't know if this is an exact example that you do it, but this is the time when people would try and do it. So do not do that. Everything needs to divide by C. This is not having everything divide by C. Therefore, this is not it. X equals A plus B all over C. Well, this one would take more work in terms of solving for X. Let's see what would happen. if we add a to both sides, we get cx equals, and you can write the a first, that's fine, positive a plus b. If we divide both sides by c, yeah, x equals a plus b all over c. That actually seems to be another one that works. So that's all good. And the last one, it's kind of a longer problem with all these things to look at. B plus a equals cx. Well, if I add a to both sides, we just saw this. If I add a to both sides right here, you can write it as b plus a or a plus b, up to you. Cx equals b plus a, or heck, b plus a equals cx. This is all good as well. I didn't solve anything, but that is equivalent as an expression. So yes, that works out. So 3 of them work, 3 of them do not. Sorry that I didn't maintain the work on this thing. I just kept rewriting things until I found out which ones worked, which ones didn't. Check the left side for the answers. Okay, number 3. Let n represent the number of solutions of the equation 3 times x minus a equals 3x minus 6. Complete each statement with the symbol less than, greater than, or equal to. So what I'm going to do is I'm going to write this equation. I'm going to copy and paste those statements, and we'll fill out the symbols. Parts A through F. Okay. Try to fit them 1, 2, 3, 4, 5, 6 lines like that. All right. Part A. When A equals 3, how does n... Wait, hold on. What is this? Oh, n represent the number of solutions. Okay, when A is 3, we would distribute this. We'd get 3x minus 9 equals 3x minus 6. 3x minus 9 equals 3x minus 6. Looks like we'll have a no solution case. The 3x's would cancel out, things like that. So there would be no solutions, therefore number of solutions would be less than 1. Less than. When A is negative 3, negative 3 would be 3x plus 9 equals 3x minus 6. Once again, 3x's would cancel, 9 equals negative 6, don't work, no solution. Number of solutions is less than 1. When A equals 2, that'd be 3x minus 6 equals 3x minus 6. That's an infinite number of solutions. That means there's more than one solution. There's an infinite number. It'd be greater than 1. When A equals negative 2, you'd get 3x plus 6 equals 3x minus 6. Once again, that looks like a no solution case. No solution case less than 1. When A equals x, interesting. If A is x, x minus x is 0. You'd get 3 times 0, which is 0 equals 3x minus 6. Now, regardless of what x is as a solution, they're not asking what x is, they're asking how many solutions are there. Just 1. This is a case where x's don't cancel. You can solve for x, whatever it is. N equals 1 would be the setup there. Looks like I did more lines here than I would have. Oh, well. And then the last one, when A equals negative x, minus negative x is plus x. That's 3 times 2x, which is 6x. So 6x equals 3x minus 6. Once again, x's don't cancel in whatever I do to solve, so I can get a solution for x, and that's just one solution. N would equal 1 in that case. Okay, number 4. You are painting your dining room white and your living room blue. You spend $132 on 5 cans of paint. The white paint costs $24 per can, and the blue paint costs $28 per can. Use the numbers and symbols to write an equation that represent how many cans of each color you bought. Okay. If you spent... Here's the thing. We have an x as a variable, and that's the only variable they allow us to do. It looks like we want to express both number of cans in terms of the same variable. Notice that you spend $24 per can on one of them. Let's see what I want to do here. And $28 per can on the other. Write an equation about how many cans of each color that you bought. But I only have one variable here. What I want to do, though, is that... Okay, here's the thing. 5 cans of paint means that however many you spent on one of them, let's call x, you spent 5 minus that on the other, right? If I bought 1 can of paint, of like white paint, then I bought 4 cans of blue paint. If I bought 3 cans of white paint, I bought 2 cans of blue paint. If I bought 0 cans of white paint, I bought 5 cans of blue paint. So if one of the variables is x for white cans, then 5 minus x can equal blue cans. So if we do that for our representation, we can say number of white cans They cost $24 per can. If we multiply $24 per can times the number of white cans, then we get how much money we spent on white cans. If we do $32 per or $28 per blue can times the number of blue cans, we'll spend this much money on blue cans. That equals $132 total. Now, were all of those variables, were all those things in use? 24 is here. X is here. We're going to use that more than once. Plus is there. 28 is here. Parenthesis 5 minus, oh, we're going to use everything. 5 minus X again. Close parenthesis. Oh, we don't use everything. Equals 132. Technically, you can kind of use times. Times isn't the same thing as X. You kind of use times with the parentheses. But that's what we did. Use the numbers and symbols to write an equation. There it is. They want us to not use anything else. And there we have it. That's part A. Part B. How much would you have saved by switching the colors of the dining room and living room? Explain. So if we turn this into $28 per can times the white cans and 24 here. Oh, we got to solve for X on these ones. So the first equation, let's solve for X. And in the second, I'm hiding the second equation for now. Let's solve for X in these things here. So 24X plus, if I distribute here, this is 20 times 5, 140 minus 28X equals 132. I like these kinds of questions. 24 minus 28 is -4. So this is 140 minus 4X equals 132. This is a kind of problem where I sometimes prefer to add the X's over, make them positive, and at the same time subtract the 132. Those become positive. You get 4X equals 8. Divide both sides by 4. You get X equals 2. Okay, we're not done on the problem, by the way, though, but I'm going to get X equals 2 for the first set there. Now, as I keep moving this down, remember, each white can, wait, hold on. How much would have you saved? I'm trying to think, because this is the number of cans. I don't think that, oh, but this swap dollars. You're still spending 132 though, right? So I got to think about how that's working itself out for this. When I do that, I'm saying how many cans I got. They still add to 132 no matter what. So am I not adding to 132 this time? Let me think about what that is. Maybe that X equals 2, we're not setting this equal to 132 anymore. We're saying using the same number of switching the colors of the dining room. Let me think about that for one sec. Hold on. Okay, so my thought of this problem is that when we solve for our scenario where we had here, X equals 2 for us is number of white cans. So this is 2 white cans and 3 blue cans. Now, as we saw, that added for us to $132. But we got to use this same scenario, 2 white cans, 3 blue cans in this part. X is still number of white cans, 5 minus X is still number of blue cans here. So what we're going to do now is let's do 28 times. Now, we already did the switch, right? X being now $28. So white cans are $28 per. So this is 28 times 2 plus 24 times 5 minus 2, or 24 times 3. So now let's compare what this dollar amount would be, because this was $132 for 2 white cans, 3 blue cans done this way. Now let's do 28 times 2, which is 56, plus 24 times 3, which is 72, and that gives you 128. So if you switch them, it's $128 spent versus $132 spent. So if you switch the cans, you save $4. 132 minus 128. So that's just a setup of switching that. Well, I switched the prices for the cans. I'm trying to think if I switch the prices for the cans or if I switch the cans by quantity. No, the cans are still 2 and 3. Anyway, so there's the idea for that one. Kind of interesting. Yeah, these questions, man, even, listen, it's IM1. I'm a teacher up to things with calculus and stuff. These questions can sometimes make me say, what were they asking? And what am I trying to do with it? All right, number 5. Which of the equations are equivalent? 6x plus 6 equals -14. Okay, to be equivalent, let's go ahead and solve for x's and figure out what's going on. Otherwise, I'll just have no idea. So I'll just do different colors here. 6x plus 6 equals -14. I'm going to subtract 6 from both sides here. and I'm going to divide both sides by 6 here. This is a weird answer, but this reduces to divide this each by 2. You get negative 10/3. So there's an answer for that one. Let's see what's equivalent to that, if anything. 8x plus 6 equals negative 2x minus 14. I can add 2x to both sides here, keep them positive, subtract 6 from both sides there. I get 10x equals, and this is negative 20, divide both sides by, negative 20, divide both sides by 10, I get x equals negative 2. So not equivalent on the first two. Let's check out this one here, 5x plus 3 equals negative 7. I can subtract 3 from both sides, and I get 5x equals negative 10. Divide both sides by 5 here. I do get x equals negative 2. So these two are equivalent right here. These two are equivalent. If you get the same value for x, they're equivalent, right? And then the last one, I can do, well, I can solve for x. 7x plus 3 equals 2x minus 13. If I subtract 2x from both sides and subtract 3 from both sides, I get 5x equals negative 16. Divide both sides by 5, I get x equals negative 16/5. Now that can't reduce as a fraction, therefore it's not the same as this fraction. Even if this decimal is around negative 3.3, you know, whereas this answer here is exactly negative 3.2. They're very close to each other's values, but they're not exact. So the only two that are the same are these two right here. They both have the same answer. The others have different answers from these and different answers from each other. Number 6, the perimeter of the triangle is 13 inches. What is the length of the shortest side? A perimeter is the addition of your sides of your triangle. So we're going to add together x minus 5 with x over 2 with 6 to get 13. As we've seen different things we can do with fractions, we haven't yet tried common denominators. I kind of don't want to do that right now. Here's what I'm going to do. I'm going to combine the negative 5 and the 6 for now and keep the x and x plus 2 separate. X and x over 2 separate, I should say. And you have one of two options here that I'd prefer. Option number 1 is rewriting this as a decimal, like this. So this becomes, let's start this in a different color. Whoops. Start this in a different color like this. So 1x plus 0.5x is 1.5x. Because it's an exact decimal, I'm actually good with it this time. Subtract 1 from both sides, and we get 1.5x equals 12. Divide both sides by 1.5, and you get x equals, I think that's 9. No, 8? I think it's 8. Is that 8? I think that's 8. Anyway, we're not done with the answer, but that's one way to do it. Another way is doing this, taking this equation and multiplying everything by 2. And I bring that up because this is divided by 2. That'll clear out if you multiply, but everything needs multiplied by 2. Every term here. I could have subtracted the 1 over, by the way. I didn't get there yet. But I get 2x plus 2 over 2 is 1. So 1x plus 2 equals 13. Now 2x plus 1x is 3x. And now I'm going to go ahead and subtract the 2 over. Oh, not 13. I'm sorry. You got to multiply it by 2, right? 26. See, I already made a mistake. Equals 26. Subtract 2 from both sides. And then you get 3x equals 24. Divide both sides by 3. This can confirm at least that x is 8. Now again, one of two ways to do it. You can also work toward common denominator, but that's my goal there. Now, what is the length of the shortest side? We got to compare all three of these. What's 8 minus 5 versus what's half of 8 versus what's 6? 8 minus 5 is 3. 8 divided by 2 is 4. And 6 is 6. 6 is 6. The length of the shortest side is 3 inches. Shortest side. And that's the answer, 3 inches. Okay. Oh, there, I didn't see it was a multiple choice option or a question, so it's going to be 3. Oh, maybe we could have plugged them in and saw what worked, but that's okay. All right, number 7. You pay $45 per month for cable TV. Your friend buys a satellite TV receiver for $99. I like they're not talking about streaming. Good. And pays $36 per month for satellite TV. Your friend claims that the expenses for a year of satellite TV are less than the expenses for a year of cable. Write and solve an equation to determine when you and your friend will have paid the same amount for TV expenses. Is your friend correct? Explain. Yeah, you have two options because it talks about the per month thing. We could almost plug in, well, we could plug in 12 months for each of these things and figure out just which one's going to be more or less. Here we're going to solve for X and figure out when they have the same amount. Number one is their request. Number two, we should be practicing algebra. So for part A, write and solve an equation when we'll have paid the same amount. 45 per month for cable TV is straight up boom like that. If you buy the satellite TV receiver for $99 over here, that's an upfront cost, and $36 per month, X is the number of months in this case, for satellite TV. I'm going to subtract 36X from both sides. Remember, we're setting them equal to find for what month do we spend the same amount. 45X minus 36X is 9X, and divide both sides by 9. Divide by 9. You get X equals 11. 11 months is part A. You spend the same amount at 11 months. Part B, we already did one of these kinds of questions before, where before or after 11 months, which one's more? You spend more before 11 months because the $99 upfront cost is really taking its toll. The 36 is going to help it over time, but not before that. At 45, here you spend less. So you spend less for the first 11 months for cable TV. You spend less after 11 months for satellite TV. So what does your friend say? The expensive year for satellite TV are less than year of cable. They're correct. My friend is correct. After 11 months, satellite TV will cost less than cable TV. And 1 year is 12 months. Again, if we substitute 12, we could also figure that out, but because 12 is more than 11, your friend's correct. All right, number 8. Place each equation into one of the four categories: no solution, one solution, two solutions, or infinitely many solutions. Let me do kind of a copy-paste job of this and see what we can just... I'm not going to be able to drag things in, but I'll start to write things into each individual part. This will look pretty small on here. Let's do what we can. Lock it in place. Lock it up. All right, so number 8. First one, absolute value of x plus 3 equals 0. There's only going to be one solution in that case. 8x plus 3 equals 0. It's either 8x plus 3 equals positive or negative 0, which is only one set of those. I'm not solving for it, but that's it. Negative 2x plus 4 equals 2x plus 4. Despite what it looks like with the variables canceling, they will not. You add 2x to both sides, and that'll give you a 4x, etc. Now, that gives you one solution in that case. That solution is actually x equals 0. Ooh, I'm probably not going to have much room for these. Hopefully, it's just 2 per or something like that. 12x minus 2x is 10x. 10x equals 10x minus 8. That's an impossibility. This would be a no solution case. 12x minus 2x equals 10x minus 8. I can't do this any, smaller. So I hope this is okay that I'm writing it this way. Negative 6 equals 5x minus 9. There's a solution. Even if it's a fraction, there's one solution. So negative 6 equals 5x minus 9. If I subtract 2 over here, I get a negative 2. An absolute value of something as negative is not possible. That's no solution there. So negative 2. Oh, sorry. Let's write the original. That would be, let me erase that. I can't see it. 0 equals absolute value of x plus 13 plus 2. You know what I should do is just write the numbers right here. 0, 1, etc. That might be better for us. Let's do that. I hope that's okay that I started that. You can keep writing them in. I'm just going to write the number next to them. 0, 1, 2, or infinite. So this had 1. This had 1. This had 0. This had 1. This had 0. This, if I divide both sides by 3, I get a positive. And therefore, this can either plus or minus that number. This gives us 2 solutions. This one, if I distribute the 3, I get 3x minus 12. Negative 12 plus 1 is negative 11. 3x minus 12 equals 3x minus 11. Not possible in that case. That's a 0 solution. Here, if I distribute, here it's negative 4x minus 16, and that's negative 4x minus 16. That's an infinitely many solutions. That's your infinite symbol. And here, negative 2x plus 4 happens here, and 4 plus 3 is 7. So negative 2x plus 7 equals 7 minus 2x. That's also an infinitely many solutions case. Infinitely many solutions. So we have this setup here. Only one of them has 2 solutions. That's the absolute value of that one right there. Hopefully that's okay that I wrote it that way, just because my room's sake was terrible on that. Last question's number 9. A car travels 1,000 feet in 12.5 seconds. Which of the expressions do not represent the average speed of the car? Well, what I'm going to do is first just represent this as distance equals rate times time. So if we solve for rate, we have to divide both sides by time. So this is going to be rate equals distance over time. So for all of these, represented by average speed of the car will be some form of distance over time. Our distance is 1,000 feet. Our time is 12.5 seconds. So we can represent rate as 1,000 feet every 12.5 seconds, which of course can probably have some sort of division. So let's see. 80 seconds per feet would be incorrect because of the units. It doesn't matter if the number's right, the units are not. 80 feet per second, we'll see. Seconds per feet here will be incorrect as well. So 80 feet per second or 80 feet over 1 second. Apparently 1,000 over 12.5 is probably 80. Let's double check that. I believe it is. It is. It's 80. So this equals 80 feet every 1 second or 80 feet per second. It doesn't matter how you write that. Either or is acceptable. Therefore, these two are totally fine. This one's incorrect because you're dividing time by distance. Otherwise, that's good. This is incorrect every which way. It's not 80 seconds per foot. 1 second per 80 feet is correct, but that's not how we represent the rate there. Actually, you know what? I take it back. Let me state this again. I take this back. Your rate... Actually, no, you know what? I don't take it back. But I do take back the answer. It says which ones do not represent the average speed of the car. Let's totally change that. Which one don't represent the average speed of the car? These do, therefore these don't. Now, what I want to state here is 1 second every 80 feet is appropriate. It's just not the rate. Our rate is distance over time, not time over distance. This is an incorrect answer, period. But they said which ones don't represent it. These ones don't represent it. There it is. All right, guys, that's your cumulative assessment portion. So chapter test, cumulative assessment. You can tell why those problems are completely different, what they're asking, what they're doing. Very wacky. And over time, listen, they only do 8, 9, or 10 questions on cumulative assessments each time. So once we get to chapter 10, they'll do like 3 of them on chapter 10 and a mix of some of the other ones from the previous chapters like that with weird questions. Anyway, guys, that'll do it for this one. This is Mr. Robinson. Thank you so much for watching. That is the end of chapter 1. In chapter 2, we start focusing on inequalities. So everything we did on solving works out there, plus a little couple things on less thans, greater thans, not a couple things. That's all that it's going to be. So thank you so much. Take care. I'll see you in the next one.